We're given the vertices to a quadrilateral and told that it's a square. And then we're asked to verify that it really is a square by showing that the diagonals are perpendicular and congruent. So the first thing I like to do is sketch, because sometimes our vertices aren't given to us in the order that we think they are. So I like to sketch them and make sure that I'm actually calculating the diagonals and not a side of the square. So I'm going to go ahead and put that on this little grid over here. So 0, -1, that's point A. -4, 5 is point B. 2, 9 is point C. And then finally 6, 3 is D. All right, so if I connect the dots here, that gives me my square. And now when I connect the diagonals, I'll be able to see exactly what I'm talking about. So the first diagonal I see here is AC, and then the other diagonal is BD. So we have to do two things. We have to show that the diagonals are perpendicular, which means we're going to have to show that they have slopes that are opposite reciprocals. And then we're also going to have to show that they're congruent, which means we have to show that they have the same distance. So we're going to need two formulas here. And those formulas are the slope formula and the distance formula. So I just want to write those down over here. The slope formula is y2 minus y1 over x2 minus x1. And the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so let's figure out, I'm going to write down our points. So I'm going to write down A and C. So A is 0, -1. C is 2, 9. Let's do our slopes first. So I'm going to label these x1, y1, x2, y2, and we'll use that for both of our formulas. All right, so for our slope, I need to do y2 minus y1. So that would be 9 minus -1. And then x2 minus x1 is 2 minus 0. 9 minus -1 is actually 9 plus 1, which is 10. 2 minus 0 is 2. And then 10 divided by 2 is 5. So the slope of AC is 5. Now let's figure out the slope of BD. So I'm going to write my points down again. So I have -4, 5 for B, and then D is 6, 3. I'm going to label my points x1, y1, x2, y2. And now I'm going to plug them into the slope formula. So I have y2 minus y1, or 3 minus 5, and then x2 minus x1, or 6 minus -4. 3 minus 5 is -2. 6 minus -4 is actually 6 plus 4, or 10. And if I simplify this, I can divide them both by 2, and it gives me -1/5. So if I look at my two slopes, they are opposite signs, and they are reciprocals of each other. So that part checks out. Now we have to find our distances. Now, to save ourselves a little bit of time, because we've talked about this before, remember that in the slope formula, the numerator of our slope, so the y2 minus y1, is the same as our second set of parentheses in the distance formula. So this right here is going to go here. And then similarly, the bottom of our slope formula is the same as the first set of parentheses in the distance formula. So this part will go here. So I'm going to put 9 minus -1 in my yellow parentheses, and then 2 minus 0 in the green parentheses. And now we can simplify. So I'm going to put everything that is in underneath the radical, but not the radical itself, into my calculator. And that's going to give me 104. Now, normally we would say, okay, let's break it down and see if we can simplify it a little bit more. But that's not exactly important here. What's really important is that we find out that the distances are the same, not necessarily that they are reduced. So let's skip over now to BD, and we'll do the distance formula, and we can do the same thing that we did before, where with the yellow and the green situation. And this one we can do a little bit faster now that we've kind of reviewed it. So in the first parentheses, I'm going to put 6 minus -4, and in the second parentheses, we'll have 3 minus 5. So now what we can do is plug all of the stuff under the radical into the calculator, and it does in fact give us 104. So I've now shown that the diagonals are perpendicular because their slopes are opposite reciprocals, and I've also shown that the diagonals are congruent because they have the same distance.